All right, we'll get going here. So thanks everyone for coming. Just a few housekeeping items before Scott does his presentation here. The first one, just a reminder that we're giving away a free growing season subscription at the end of this presentation. So make sure to be attendance at the end of the talk when we're giving away the subscription. And just a reminder to everyone that this presentation is being recorded and will be posted later on our YouTube channel. And if you have any questions throughout the presentation, feel free to post in the chat box in Microsoft Teams here, and we will answer all questions at the end of Scott's presentation. So feel free to do that. And otherwise, I'll get to it here, just introducing Scott. Scott is the president and chief scientist at Weatherlogics. He attended the University of Manitoba, where he completed both his bachelor's and master's degree in meteorology. In his current role as chief scientist at Weatherlogics, Scott conducts weather research and develops tools to help clients plan for all types of weather conditions. This includes new methods to improve weather prediction and the analysis of past weather events. Despite his research focus, Scott still enjoys forecasting day-to-day weather and is often involved in preparing forecasts for high-impact events. So take it away from there, Scott.
Thanks, Matt, and thanks everybody for joining us today. I'm looking forward to giving my presentation on our summer outlook. And as part of the presentation today, we'll talk about a few other things as well. We'll give you a bit of background on what normal weather is, what affects prairie climate. And our previous webinar was about the 2021 drought. For those that missed that, we'll quickly go over the details of that and how it may affect the upcoming summer as well. And then, of course, giving the big reveal at the end for the summer outlook and wrapping up with some of the new things with our forecasting this year. So first of all, what is normal weather? This is a very important concept when we're talking about any kind of forecast, because most weather forecasts, especially in the long range, are compared to normal. And the word normal really is just referring to a statistic, which is the average of the weather conditions at a location over about the past 30 years. In most cases, when you read the normal high for today, that will be the average over the past 30 years on that day. So today, at the end of March, it's March 29th. So if we take the data on March 29th from 1991 to 2020 and average it, that's what would give that number. Same thing can be said for precipitation. So we would average the last 30 Marches to get the average March precipitation, for example. We're using 1991 to 2020 averages right now. They don't update every year, but usually they're updated once a decade. But you have to remember that normal is really just a statistic. If you take the 30 Marches from 91 to 2020, they would have all been very different. So the average is just kind of the statistic representing all those Marches, but you have to remember that there are probably actually very few that were exactly normal. There's some variation there. So just for some examples, across the prairies, what does normal look like? This is the winter season, which we're just coming out of. So in the winter time, the western prairies, especially in Alberta along the foothills, are the warmest part. Average winter temperatures are in the minus single digits, so around Calgary, for example, minus 7 or 6. Whereas if you go through Saskatchewan, average temperatures slowly drop off, and then by the time you get into Manitoba, you see the coldest winter temperatures. So in January, the normal high in Winnipeg is minus 11, Regina minus 9, and Calgary minus 1. So quite a dramatic change actually across the prairies. And the reason Alberta tends to be so much warmer is because of the mountains. There's steep terrain, and as the air descends off the mountains, it warms very rapidly, allowing for those warmer temperatures, whereas in the eastern prairies, very little difference in terrain, and so there's not the ability for that rapid warming to occur very often. In July, though, the trend is actually reversed, and Calgary becomes the coldest because it's at the highest elevation, and then Regina and Winnipeg are warmest as they're much lower elevation. So here's what that summer map looks like from June through August. You can see the Red River Valley of Manitoba as the warmest part of the prairies because it receives the warmest high temperatures and also rather warm low temperatures. Most of Saskatchewan has similar high temperatures to Manitoba in the summer, but typically colder at night because it's a drier air mass, and similar in southeastern Alberta, also quite hot during the day, but colder at night. And then as you get into the higher terrain, just ahead of the mountains, that's where things really start to cool off, and you get the coldest summer temperatures. And really in places even like Calgary, snow is a possibility any month of the year. Really the only month that snow is very unlikely is July, but I believe it has happened before. So here's just another look at that map. And one other thing I'd point out is that some of the little anomalies you see on the map, so there's some little cool pockets here in western Manitoba, eastern Saskatchewan, also here in southeastern Alberta and southwestern Saskatchewan. Those are terrain. So in this example here in the southwestern part of Saskatchewan, that's the Cypress Hills. And these features are the Riding Mountains, Duck Mountains, Porcupine Mountains from Manitoba into Saskatchewan. Now, what about the growing season? Well, very similar to the summertime temperature trends, except this map is showing what's normal for the entire period from May through September. So you see that a lot of areas are the same in the southern prairies, and what tends to happen is places like southern Manitoba are the warmest in midsummer, but they start to cool off a little bit more in the fall and are a little bit perhaps cooler to start in the spring. So things average out a bit more. So pretty much from southeastern Alberta through southern Saskatchewan to southern Manitoba, very similar growing season temperatures on the whole. But then you still get some of the colder values along the foothills of Alberta, and also as you get farther north in the prairies, of course, things cool off a bit. But if you do the entire growing season as a whole, average temperatures don't vary quite as much as if you focus simply on one season. Now, what about precipitation normals? Very important consideration for agriculture, and also quite some dramatic differences from west to east. So starting in winter, as an example, these statistics here are for Winnipeg, Regina, and Calgary, again, just as big centers, but if you're in the vicinity of those locations, you won't see too much difference. But as you can see in January, very dry, Calgary only 11 millimeters being normal, about a half inch, Winnipeg 17 millimeters or almost 3/4 of an inch. So winter is a very dry season. Then in July, for most areas, the wettest month or one of the wettest months, and precipitation dramatically higher, so 2 to 3 inches in most of these cities. Now the map here is showing for the for the year as a whole. In southeastern Alberta, we have the driest part of the prairies, where in some areas, like around Brooks, only about 11 inches of precipitation, or 270 millimeters, is normal for the entire year. So not a very wet climate at all. In fact, it's nearly a desert type environment in that part of Alberta and adjacent parts of Saskatchewan. Contrast that as you move to the east, things slowly get wetter through Saskatchewan. And then by the time you get into Manitoba, you see this kind of wetter corridor through the eastern part of the province. And that's catching a lot of those stronger systems coming out of the United States. So by the time you get into the far southeast of Manitoba, we're talking about over double normal precipitation that you get in southeastern Alberta. So more like 26 inches is normal in the far southeast. So quite a difference in precipitation regimes. And so if you're growing crops in southern Alberta, you've got very different circumstances than in southern Manitoba. And in Saskatchewan, you're very much in between. The west behaves more like Alberta, and the east is more like western Manitoba. Now for growing season normal precipitation, the pattern mimics very much the year as a whole. The reason being is, like I said earlier, winter is a fairly dry season for all of the prairies, so it doesn't play into the growing or the year as a whole very much. But the growing season is the wettest time of year, so you can see it mimics the annual trends, with southeastern Alberta being the driest, and again around Brooks, only about 6 inches or 150 millimeters being normal from April through July. And I picked April through July because it's kind of a critical window for crops. Whereas in the Red River Valley of Manitoba Southeast, you're talking about more like 14 inches. So we're 2.5 times more. And Saskatchewan, again, transition quite dry in the west and getting much wetter by the time you get to the east. So these are normal values and something that I would watch closely if I was growing crops because it tells me what's a baseline. If this is normal and I need more than normal to get a good crop, I know that that's going to happen not very often. It will happen some years, but not every year. In fact, it won't happen more often than not. So something I would look at quite closely. So that's a sense of normal to start with, and that's important to consider as we get into the outlook later, because I'll talk about what areas are expected to be above normal and below normal. So the forecast is kind of relative to where you live. Now talking about what impacts prairie climate, and these are all very important considerations when making an outlook, because these are the things that control our day-to-day weather. The first thing, and one of the factors that really influences day-to-day weather, is where the jet stream is located. The jet stream is a divider of warm and cold air masses, with cold air masses being to its north and warm to its south. And in fact, the jet stream is driven by those large temperature contrasts. It's located about 10 kilometers above the ground, hence why it's called the jet stream, because jet airplanes tend to fly through it. And it can often exceed 300 kilometers per hour. When it becomes wavy or deflects way up to the north or to the south, that's when you tend to get the more extreme weather patterns. So typically, if it's deflected well to the south, that's where you would tend to get the more unsettled conditions. So here's a map showing what that looks like. I've labeled this deflection to the south in BC as a trough. So that's what it's called when it's deflected like that. It's a trough. When it's way up to the north, that's a ridge. And then in eastern Canada, another trough. Now, this type of a pattern would tend to bring calm and hot weather to the central eastern prairies in summer, and with a trough encroaching on Alberta here, that would tend to bring more cool and unsettled conditions. Now, in in the growing season, if you get a pattern like this, it's actually not too different from what we saw for a lot of last summer, where the eastern prairies especially was trapped under this really hot, dry weather for prolonged periods of time, so not a lot of rainfall, not even a lot of thunderstorms. In Alberta, also a fair bit of hot, dry weather last year as well, but there were more periods where those troughs impinged and gave some more unsettled conditions, especially in areas a little farther north in the province. Now, many of you may have barometers, and there's actually a connection between the jet stream and your barometer. Because the barometer, of course, detects changes in pressure, but it's only detecting that change at the surface. However, the changes in pressure at the surface are being driven by what's happening in the upper part of the atmosphere. So if you have a jet stream aloft that's moving very quickly overhead and spreading out, it's causing the air up above you to diverge. So it's kind of pulling air apart above you. And because of that, it's kind of creating a vacuum. So air wants to rise up into that region where air is being pulled apart by the jet stream. And because air is rising away from the surface, it's decreasing the pressure at the surface. And that's where you get these areas of low pressure developing. And that's usually the more unsettled weather. On the other hand, the high pressure causes air aloft to converge. So the wind is causing air to build up higher up in the atmosphere, and that's forcing it to sink, creating high pressure, which would cause your barometer to rise. So just because your barometer is rising or falling doesn't automatically mean the weather is going to change to be more unsettled if it's falling or calm if it's rising. But that implies that there's a change happening aloft and something to keep an eye on. Oftentimes, especially in winter, some of the worst weather happens when the barometer is rising rapidly as a low pressure system departs. We saw that a lot this winter with Alberta clippers moving across the prairies. They'd move through, pressure would fall, they'd drop a bit of snow, and then as the system departed, the barometer would rise rapidly, but winds would pick up and create blizzard conditions. And agriculture also influences weather, especially in the growing season where there's crops. The crops that are growing across the prairies and across the United States are an important part of the water cycle. The water cycle is influenced by crops because as the rain falls and absorbs into the soil, that moisture is then able to be taken up by the plant and either transpire through the leaves, or if it doesn't go up into the plant, it can evaporate straight from the soil. And the combination of transpiration and evaporation is often grouped together and called evapotranspiration. Now, those two factors are releasing moisture back to the atmosphere. And if we have a lot of soil moisture and we've got very healthy crops, those crops and that soil is able to release a lot more moisture back to the atmosphere. And so then what we get is a feedback that begins to develop. The moisture is released back to the atmosphere by the soil and the plants. That's able to fuel more precipitation, which in turn replenishes that moisture and starts it all over again. And as you can imagine, if there's a lack of soil moisture, it causes the opposite. So the plants are not releasing as much, nor is the soil. Therefore, there's less moisture in the atmosphere to produce more precipitation, and things continue to dry. And that's more along the lines of what we've seen in the last few years. Now, it's not a process which is permanent or which can't be changed. Large-scale changes in the weather, like shifts in the jet stream, which influence weather on a really large scale, like across a continent, that can break this type of a cycle. But absent a large change in the overall weather pattern, this type of a feedback can continue. And unfortunately, we've seen some of that the past few years, although that's not the only cause of the drought. The drought has also been caused by other factors, which I'll talk about, but this does definitely make it worse in some cases. And the type of crop can also influence the amount of moisture released to the atmosphere. Corn is notorious for releasing a lot of moisture. Well, of course, requires a lot of moisture to grow, and 1 acre of corn can transpire or release about 400,000 gallons of water per growing season if it's a really healthy crop. And it could release as much as 10 millimeters of water vapor per day at peak growth, assuming it has as much moisture as it needs to grow rapidly. Wheat is not as much of a transpirer, but it still does produce a fair amount at peak growth, so more like 5 millimeters. And even this could raise relative humidity in a day by about 10%. So you can imagine if it's a day when thunderstorms are forecast and the humidity is increased by 10%, that could either fuel more powerful storms, or in some cases, if it's a marginal thunderstorm event, it might be the difference between allowing storms to form or not at all. And in the prairies, despite the fact that we don't have as persistently humid weather as Eastern Canada or the United States, we actually do hold the Humidex record for Canada, which was set in Carmen on July 25th, 2007. The Humidex hit 53. And at the time, it wasn't even really that hot. Well, it was hot, but nothing extreme. It was 35 degrees air temperature. But the humidity was incredibly high, which resulted in that Humidex. And not surprisingly, that happened near a cornfield, which was quite healthy that year, and likely the corn was very healthy throughout the Red River Valley and northern U.S. as well. And like I mentioned, agriculture can influence thunderstorms. So thunderstorms are an important source of rain during the growing season, and thunderstorms are driven largely by moisture in the atmosphere. So many people think of thunderstorms as being a phenomenon that happens when it's really hot out in summer, which is true. It does usually have to be hot, although not necessarily. But really, it's the humidity. It has to be hot and humid. That's the worst case for thunderstorms. You can also get them when it's cool and humid. I've even seen thunderstorms when temperatures are near or just below freezing, if there's enough humidity. And as we've changed our grasslands on the prairies to annual crops, this has also changed the thunderstorm trends. Because of the change to annual crops, the thunderstorm season now starts a bit later and is shorter because the crops that we plant release the moisture later in the spring, or start later in the spring and end earlier in the fall, whereas the grasses would start growing earlier in the spring and last later into the fall. So the grasses would release less moisture at their peak. So here you can see in July, the peak released, and therefore the peak in thunderstorm activity was a bit lower, but the season as a whole was longer. But now with the agricultural prairies, the peak is higher, but the season is a little bit more compact. So the type of crops will influence this, and the fact that we've got moisture releasing crops, especially large moisture releasers like corn just to our south through the northern US and parts of the southern prairies, plays a role in this. And so this research was done a while ago at the University of Manitoba showing how this factor influences weather. So some of the factors there that influence prairie weather. Now let's talk about the drought of last year. And for those that watched our prairie climate webinar, we talked about this a bit. Well, I shouldn't say a bit. That's mostly what it was about. But I started by defining drought because this is a very important part of understanding what's going on. Drought is not necessarily just purely a statistical measure. It can be, and that's what meteorological drought is. But on the whole, a drought is generally just defined as a period of abnormally dry weather sufficiently long to cause a serious hydrological imbalance. In short and in simple terms, basically meaning more water is leaving our system than entering. And over time, that's causing the soil to dry out and the environment to dry out. Now, meteorological drought is just a statistic. So Saskatchewan, let's say, received 150 millimeters less rain than normal. That could be considered a drought condition because that's well below normal for them. In agriculture, really all we care about is whether or not the crops have enough moisture to grow as they should. So if the crops fail due to a lack of moisture or crops underperform due to a lack of moisture, that would be an agricultural drought, and that's what we've seen the last few years, and last year especially. Hydrological drought would be impact on water resources like rivers or lakes. So last year, the Red River in Manitoba nearly dried up south of Winnipeg, which is quite an unusual event and strong indication of the lack of moisture entering the system. Socioeconomic drought is the impact on society, so that could be lower spending by farmers due to a lack of production, or could be food shortages caused by agricultural drought. Various impacts could be economic or on society. But the fact is, drought is very complicated because simply looking at a statistic doesn't necessarily tell us how it will impact on agriculture. In parts of the prairies, if you look at last year as a whole, or year like 2019 as a whole, it was definitely below normal in terms of precipitation, but not dramatically so, especially I think it was 2019. We had a very wet fall, so the year as a whole was actually not really that dry. And the growing season was, in some areas, actually wetter than normal. But the rain didn't arrive at the right time. It arrived in the fall when it was too late. On the other hand, you might have a whole bunch of wet years in a row. So let's say for 5 years in a row, you had double your normal rainfall. Then on the 6th year, you had half your normal rainfall. So the 6th year would statistically be a very dry year. But because of all the moisture that may still be left in the soil, if you've got a soil that holds moisture well, the 6th year might actually be a very good year because you've got the soil moisture you need in place, no extra moisture coming to make it difficult to get out on the fields. And so that could be actually great conditions. But if your soil can't hold moisture very well and needs that moisture every year to keep going, the 6th year might be a problem. So it depends on a lot of things, not just the amount of rain, also soil conditions and so on. Also depends where you live. Some people can tolerate less rain than others. In Alberta, I showed earlier that 12 inches of precipitation in the southeast in an entire year could be normal. But for an Illinois corn farmer, 300 millimeters would probably be the driest year on record and likely a disaster because they're counting on about 1,000 millimeters a year. That's normal for them. You take that 1,000 millimeters and bring it to Manitoba, you'll have a flood because a lot of people are at the bottom of an ancient lake and the soil simply can't handle that type of moisture. You'd have a massive flood. So for farmers, my point is agricultural drought's all that matters. And that means, was there moisture at the right time to grow a high yielding crop? And last year we saw most of the prairies was drier than normal. So this is the map that shows precipitation trends for April 1st to October 25th of last year. So you have to bear in mind that this also considers the fall, which turned a bit wetter. But if you look as a whole, anywhere that's in yellow, orange, red was below normal for that time period. And then the greens are above normal. This area here that's above normal I would say largely due to precipitation in fall. If you remove the fall, this area is probably more in the normal to below normal range as well. So really most of the prairies was impacted, except in the north was wetter, but really not much agriculture there. You look at a place like Saskatoon, incredibly dry. I think only about 150 millimeters in the year as a whole, actually. I got the graphs coming up. And in Manitoba, very dry, especially early in the year, and even Alberta got into drier weather this time. So here are some charts showing precipitation for select places in Alberta for 2021. The graph is showing April through October. So the bars are showing monthly precipitation, and then the line is showing cumulative. So I've kind of highlighted July here. So up till July in Calgary, the line here is showing there's about 140 millimeters of rain. But normal is the star. So up to that point, normally there would have been about 250. So you see at all these locations, Lethbridge, Lloydminster, Edmonton, the star is above the line, indicating that there was less rain than normal through July. And some places like Lethbridge especially, dry climate to begin with, only about 200 millimeters being normal up to that point in the year, and they only had about 80. If we move to Saskatchewan, similar story. Regina was actually one of the closest to normal through July, but it still wasn't a lot of rain, really. It was only about 170 millimeters up to that point. Saskatoon, well below normal, only 100, whereas 200 would be normal. And then Yorkton and Swift Current also quite dry. Swift Current especially getting into that drier climate in the southwest of Saskatchewan. It's only 100 millimeters up till July versus 200 normal. And Manitoba, really not much new here. I guess the main thing to note is that through July, very dry in pretty much every location. August, though, you see the bar goes way up. So August was a wet month, which definitely helped some folks who could still benefit at that time. But earlier in the year, very dry. And even a place like Morden, which is one of the wetter stations on the prairies, only 100 millimeters through July, which is very unusual. Normally they would have had more than 250 by that point. So quickly highlighting recent trends in prairie climate. So is this dry weather something new, or is it just an anomaly that will go away? And if we look at the data, this is from a research study published for Canada in a atmospheric journal. What they found is that on the prairies, there's actually been no change in precipitation on average in terms of significant change. No change in extreme heat either. So these are, you can basically take these as being growing season stats. The growing season has gotten us a little bit longer though, about 10 days longer on average, and about 95 more growing degree days. So for the growing season, no significant changes really, just a little bit longer. That would be the main one. Now, just because there's been no changes in these metrics doesn't mean that year to year there won't be extremes, but over time those extremes balance out. If you look back over time, you can probably imagine, or not imagine, but remember there have been some really wet years and some very dry years, but on the whole, those tend to average out and result in limited overall change. And that type of extreme weather on the prairies is something that's been a part of our climate for a long time and will continue to be. So that in itself doesn't appear to really be new. On the other hand, though, winters have warmed significantly, so there have been a large reduction in the number of freezing days and a reduction in minimum winter temperatures. Many folks, especially on the eastern prairies, probably think of this winter as being a really nasty one, really cold, but actually in terms of cold, it ranks very low. We're not talking about anything significant at all. In Saskatchewan, many areas would probably not rank in the top 40 or 50 coldest winters. In Manitoba, not in the top 30. In Alberta, it was actually a milder winter, so certainly no rank there at all. And what about the dry cycle? Well, here I'll highlight Saskatoon because it's an area that's been really badly affected by this dry cycle, and parts of western Saskatchewan as well. You can see on the bar graph here, any years that have a red bar pointing down had below normal precipitation. The red bar, the larger the red bar, the more below normal it was. And any years with a blue bar would have been above normal. So you can see really only 2012 was above normal in terms of precipitation over the past decade or so. A couple of years that were near normal, so 2014 and 2016, very close to normal. But of great concern is the last 5 years, which have all been fairly far below normal and appears to be continuing a trend of generally below normal precipitation over this decade. And if we look back in history, we actually do see that dry cycles are pretty common. The 1930s, of course, very dry, the 80s, in the Western Prairies, early 2000s. And on the other hand, wet cycles are also a theme as well. In the Eastern Prairies, the late 90s, early 2000s, very wet in many areas. So if we look at the history, typically what we see is 10 to 20 years of wet weather followed by 10 to 20 years of dry weather. So these cycles are something that tend to repeat themselves. And the good news is we're about 10 years into this dry cycle, which means it could break at any time. The bad news is that they can sometimes last 20 years, so we may only be halfway through. Whether it's going to break or not, very difficult to predict much in advance, but I'll talk a little bit more about that in my outlook. We think that the reason they last so long is because they're linked to Pacific Ocean temperatures. Research has shown perhaps mostly linked to northern Pacific Ocean temperatures. And ocean temperatures change very slowly, which would explain why these trends last for so long. Now a quick update on how the winter's gone. So here's precipitation from November 1st through March 23rd. So what does winter precipitation look like? Well, it depends where you are. In parts of Alberta, it hasn't been an especially snowy winter, especially in the south. Around Edmonton, a little bit snowier, but nothing dramatic. I think fairly close to normal. Through Saskatchewan, southern areas have been drier, northern areas a little bit snowier. And then in Manitoba, especially the kind of eastern half of southern Manitoba has been very snowy. Winnipeg, 170 centimeters up till now, which is ranking and probably up to this point at least would be in the top 10 or so snowiest winters on record. Up till the end of February, it was in the top 3 or 4 snowiest, but it's gotten a little drier of late. Regardless, though, a lot of snow there. Western Manitoba, it's showing quite dry here, but I'm thinking the map has some inaccuracies to it. So Western Manitoba hasn't been as snowy as eastern and southeastern Manitoba, but I don't think this is accurate. So you can kind of disregard that. What about cold? Well, like I said, the Eastern Prairies have felt it was a cold winter. So this was a February temperature trend. Eastern Prairies were quite cold in February, but it wasn't record-breaking by any means. In the West, it was actually a relatively normal February, much milder temperatures. And here I'm noting for the winter as a whole, select locations here in the East, really not even ranking anywhere close to a record. So in Manitoba, we're talking about this winter not even being in the top 30, and Saskatchewan not in the top 40 or 50. Alberta actually was a very normal winter, so it wouldn't rank anywhere at all. All right, so let's get into the outlook now for 2022. First of all, how do we make the outlook? Well, there's a number of factors that we look at. I've gone through a few of them already, so I've given you a lot of context about recent weather patterns, how the winter's gone, and also how last year went. We look at something called analogs, which are years in the past that we think will be similar to this upcoming year. We look at temperatures in the oceans. So I mentioned how the Pacific Ocean perhaps influences our wet and dry cycles, but another thing called La Nina, which is the temperatures in the central Pacific, influence our weather, especially in the wintertime. And right now we have La Nina in the central Pacific, which is colder than normal ocean temperatures there, which typically bring colder and snowier winters to parts of the prairies, and we've certainly seen that in the east. Other atmospheric circulation like the Arctic Oscillation or various other oscillations, which I won't get into the details, but these are kind of, in the case of the Arctic Oscillation, at least a wobble of cold air away from the pole or toward the pole, influencing our weather. And lastly, carefully studying the climate of the prairies to understand how our weather tends to behave and our climate tends to behave over time. So first of all, I'll show our temperature outlook for this upcoming year. So this temperature outlook is mostly focused on the summer, so kind of you can think of it June through August, but I'll also talk a bit about the spring here as well. So our forecast is for another hot summer. We anticipate fairly similar conditions to last year overall. Likely not quite as hot, especially in the eastern prairies where there were a lot of extreme heat days. Probably not a repeat of that, but still hotter than normal overall. This is because we're anticipating a ridge of high pressure to remain fairly consistently over the prairies through the core of the summer. Now, the spring will likely be colder, especially to start. In places like eastern Saskatchewan and Manitoba, where the snowpack is very deep, that's strongly correlated with a cool start to spring, and we're already seeing that. So I would anticipate it'll get off to a slower start, so cooler to start the spring, and then transitioning hotter as we get more into the core of summer. Alberta will see probably more normal conditions to start, as the snowpack there is a lot less or gone in some cases, so won't be as much of a factor, but do anticipate it getting hotter there as well as we get into the core of summer. Now the rain outlook, this is the part that I unfortunately have to share, but the outlook at this point is for a drier summer once again. Now, like the temperature trends, we anticipate the spring being a little bit different. I think it will probably start with closer to normal precipitation through the months of April and perhaps into May. But then again, as we get into the core of summer, turning drier. The unfortunate thing is that many people thought because of this snowy winter that many people have had, that would translate into a wetter summer. The issue I see in that theory is that the active weather we've seen so far over the winter is not the type of pattern that brings a lot of summer precipitation. The reason being, a lot of the weather that we got this winter was Alberta clippers, which travel from northwest to southeast, so they originate in Alberta and travel rapidly southeast. And in summertime, that's simply not a pattern that tends to give heavy precipitation events. If you want those heavier soaking rains, you want systems coming up from the south, bringing up a lot of moisture from the US. And we simply haven't seen much of that this winter. Occasionally, we'll see something kind of resembling that, but really that hasn't been the big impact. The Alberta clippers have been dominant, and that's simply not a pattern that's going to bring a lot of moisture in summertime. So we anticipate, like I said, spring starting out a little bit closer to normal in terms of precipitation, and then turning drier into the core of summer again. Caveat, of course, being the thunderstorm aspect. Thunderstorms are a very important driver of growing season precipitation, and they're highly localized. So we've seen in some parts of the prairies, you can get an entire month's worth of precipitation within a few hours from a thunderstorm. And thunderstorms may only impact a tiny area. They can't be predicted more than a few days in advance. So it's impossible to know who's going to get a lot of thunderstorms this year. But what we're doing is kind of outlining areas here where we think will be more active in general for thunderstorms. So in general, we're saying Alberta probably a little more active in terms of storms. The foothills are a great generator of thunderstorms. The dark, high elevation terrain loves to give way to storms as you move into the afternoon hours and things heat up. They then roll off the foothills onto the plains, unfortunately often causing hail damage. Also part of the reason why the area from kind of Calgary and just north is called Hail Alley. So that area we anticipate will be more active this year than last, although it's typically active almost every year because of the foothills impact. Then as we shift to the east, Saskatchewan likely seeing generally similar thunderstorm activity to last year. Last year we did see some very intense storms, especially late in the year, and in some parts of Saskatchewan, Moose Jaw, Regina, and eastern areas got some pretty severe hailstorms. So we anticipate that happening again, not necessarily in the same areas though, but occasional severe storms through some of those areas. And then as we get into Manitoba, Manitoba was a very inactive province for storms last year, which was good in some sense because hail claims were way down, but it was bad in the sense that some of those thunderstorms could have been useful to add growing season moisture. As long as you avoid the hail and the wind, those thunderstorms can be quite beneficial to adding moisture, but we didn't see a whole lot of that last year. And we anticipate similarly inactive weather in Manitoba this summer. So that's our forecast. What I now wanted to do was quickly give you a snapshot of a couple other organizations that do summer forecasting, just to show you some other opinions. I, as you'll see, really have no reason to strongly disagree because these other agencies are more or less in agreement to what I've shown. So this is the European model, and I'll emphasize that this is a model prediction, not a human prediction, but it's showing through the growing season. So I believe these charts are, well, these are actually May to July, so this is a little earlier. But regardless, you can see hot weather in red showing up through most of the prairies here, and it's showing that dry signal as well, with the browns being below normal. And then if for folks in Eastern Canada, which I haven't talked much about, we're anticipating a little bit wetter weather, so you see more of a green signal there. And on the whole, though, for really all of Southern Canada, looking like a hotter summer. I would personally put Eastern Canada a bit cooler because I think that, like last couple of years, they'll probably see more troughing and more cooler, wetter weather. But on the whole, I think this map is reasonably accurate, and they're suggesting some of the hot, dry weather may enter the month of May as well, although bear in mind this is average for that 3-month period as a whole, and I think May has the best chance of being a little bit cooler and wetter, especially on the prairies. And from the US, they've got also similar trends to what we're showing. So you can see that they're anticipating hotter weather extending into the southern prairies, especially the southeastern prairies. They do have the hotter weather into eastern Canada, but like us, they have the drier weather kind of into the prairies. Not as much in the east, though. We think that the east will be dry as well, so that's a little bit of a difference there, but they do again have some wetter signals in the east, eastern Canada, I should say. So on the whole, not massive disagreements between other agencies, but we're kind of more broadly saying the prairies as a whole will be hot and dry, whereas these other groups are not showing it necessarily as a whole, more certain parts. So that's our outlook for the summer. We hope that, I actually do hope that I'm wrong for once, because I would like to see some wetter conditions for farmers who need it, but that is our best prediction right now, what to anticipate this summer. So lastly, talking a little bit about how we help farmers, and for those of you who are subscribers, I wanted to talk about some new things, because Weatherlogix has an app which many of you probably are aware of, but may not have used a lot. And I wanted to really emphasize that this is something that you'll want to take a look at, because we've done a ton of work on this over the last year. It's been, seen dramatic changes. There's tons of stuff in there that you're going to find very useful. So if you haven't been in your app lately, make sure to check that out again, and here I'll highlight some things. Now, for those of you that aren't subscribers, I want to talk just quickly about our service first. So we have a forecast service where we provide a daily forecast for your farm. Now, as part of this forecast, what we do is email you the weather forecast at your location that our meteorologists have prepared. So we are emailing you a 5-day forecast with everything you need: temperature, wind, precipitation, and various other variables. We give you daily forecasts and hourly forecasts. Lots of good graphs and tables are available in the app, with even more detail than we can show in an email. Email is a bit limiting, so make sure to check your app for the tables and graphs and everything. It's quite useful. We also include a written discussion. The written discussion is kind of a synopsis for your province in terms of what weather is coming up and the activity. So bear in mind that the 5-day forecast is the part specifically for where you are. We also provide maps like this. People really love these for planning spraying. So you can see here on this map, wind, speed, direction, and gusts. We've got wind data forecast for the next 5 days. And in the app, especially, some really good tables showing it by hour and by 3-hour blocks. There's long-range forecast for the next 16 days, where we provide a more realistic long-range forecast based on many sources, showing when there's a more reasonable chance for rain, and we give very detailed probabilities of certain amounts of rain. We've got significant weather updates which go out during major storms. So if there's a major rainstorm or thunderstorm event, we'll send out an update during the day. The email comes out early in the morning, but those updates come out later. And the app's got lots of details that you'll want to look at, especially for those of you that subscribe year-round. We've got highway condition forecasts, we've got radar, weather stations, highway cameras, all sorts of great stuff, current road conditions. So make sure to look at that. That's all on the interactive map page. Spray forecast, a very useful thing. So this is a premium feature. For those that are premium subscribers, this is in your app. So make sure to check this out. This is a really great thing where we show you by hour what is the inversion strength. So is there a strong, weak, or no inversion? And I'll explain in a moment why that matters. What's the wind speed, air temperature, relative humidity, and then overall spray cast. So is the spray cast good, fair, or poor? And that really helps you plan out your windows because it's showing you all the data at a glance in your app. On the same page called Agriculture Risk, you also see your disease model forecast at your location and your frost forecast. So just to highlight inversions, because this is something that's often mentioned but maybe not well understood. Inversions are very important for spraying, almost as important as wind speed. Because if you've got an inversion in place, what that means is the air mass over your field is very stable. And when you have a stable air mass, the spray particles are not able to mix down into your crop. What happens is they just simply float off the field, basically at the level they were released. And these inversions are when the temperature increases with height. So these commonly happen in the early evening, early morning, and overnight. Inversions are almost always present at night, and they begin to develop in the evening and end in the morning when the sun comes up. But you can also get inversions during the day. If a front is passing through, the fronts can affect the temperature profile and cause an inversion. And in winter, not that you'll be spraying, but inversions are present almost every day in winter, even during the day, because Arctic air masses are actually coldest often near the surface itself. So what you want is a day with light to moderate wind speeds and sunny conditions. That's the most likely chance you'll have of not seeing an inversion. What then happens is air is rising from the surface and becoming very turbulent, so you get gusty weather. You don't want huge gusts, but little minor gusts is okay. And that helps to mix the spray particles into the crop, so you get these turbulent thermals mixing things and pushing the particles into the crop, versus under stable, usually calmer weather, they'll just float right off the field. So you'll want to keep an eye on that. And we've got a video actually talking about that on our YouTube page as well. So you can take a look at that. Lastly, what's new this year? This is really exciting. So we've got forecasts now every day. We're doing Sundays as well, so you'll get an updated forecast every day. We won't be updating our discussion just to give forecaster a break, but everything else, the 5-day forecast, all the maps, all that will be updating every day. We'll be showing you daily weather summaries at your location. So we've developed a virtual weather station, which shows you how much rain fell at your location and what the temperatures were. We don't require any weather station or rain gauges. We've got a quite an accurate way of doing it. It's not absolutely perfect. It won't be quite exactly the same as a rain gauge, but I've been monitoring mine this winter, and frankly, it's almost been identical to my weather station all the time. So I'm really excited about how that's working. We'll also have hail maps showing you where hail happened the previous day, both in terms of what was the hail size at various locations and the hail intensity. So what was the duration of the hail, kind of multiplied by the size of it, giving you the overall impact. So that'll be in your email, and that'll be a really important feature to help you see if you need to scout. There'll also be frost maps as well, showing if there was frost overnight. There'll be rain maps showing rainfall distribution across your region as well. So that's all going to be in the email. We'll also have regular seasonal forecast updates for the next 3 months in the email. And as I said, many improvements to the app. So I'll emphasize again, check out your app because there's so much there. Current conditions, radar, highway forecast, maps, tables, graphs. You can even put in your own alerts. You can get alerts sent to you when the forecast shows certain things or when a weather station near you gets really windy. So much there. We'll definitely be sending out emails to highlight some of that over the next little while, but I would strongly encourage you to check out the app. And just to close up, these new features I'm talking about these are called premium features. So if you're a basic user, you're not going to see these, but you can easily upgrade to premium. And if you have questions about that, feel free to get in touch. So for those of you that aren't subscribers, go to weatherlogix.com/agriculture. You can do that right now. Get a free trial going. You get it free for a month, and you can get access to all the stuff. The free trial is premium, so you'll see all the things that I'm talking about. For those of you that are already premium, all the new features will be starting up next week, so keep an eye on that. And feel free to get in touch with me if you have any questions as well. So really excited about everything that is coming this year. So it's been great to talk to you today about the summer outlook, and I imagine we'll have some questions coming up here, so happy to take those now, and appreciate you joining us.
Great, thanks, Scott, and thanks for everyone that attended the talk. If you have any questions, feel free to post in the chat here, and while we answer a few questions, I will draw the name for the subscription winner. All right, first question here, I'll just start off with for Scott. I see there's a question in that chat that just popped up. Can you clarify that Weatherlogix has an app, or is it a link to a website, Scott?
Yeah, that's a great question, actually, from Chad. So our app is a new type of app. What happens is you get a link to a website, like Chad said. All you do is you press add to home screen on your phone. So there's usually when you're in your browser on your phone, there's a button usually along the bottom which allows you to add it to the home screen. This creates a shortcut link, which is the app on the home screen of your phone. Weatherlogix website, by doing that, knows that it's installing an app on your phone. So you're not going to find the app in the App Store. You just go to the link that we send you, add to home screen, and that is how the app is installed. Once it's installed, you just click it like any other app. We do this because for corporate users, it can be complicated to get people App Store accounts and so on. So we've used this new technology, and it's really good because you don't have to log into any app stores. You just go to the link we send you, press add to home screen, and it's done. So we've also got a video on our YouTube channel about how to do that, and we'll send out some more emails about how to do it.
All right, thanks, Scott, for that. Hopefully that answered your question, Chad. Mike has a question in the chat. CFS V2 weather model is showing above normal precipitation for June and slightly below for July and August. How accurate is the CFS model?
So the CFS model is an American long-range weather model. I personally don't use it. I've found it to be very inaccurate, so I wouldn't personally read anything into that. I think that what I've presented today, my justification, is the best prediction we've got right now. So I generally don't encourage people to look at any one model in particular at any time, and especially the CFS, I found it to be quite inaccurate.
Okay, thanks, Scott. I concur with that. And a couple more questions just popping up in the chat with regards to subscription. And while Scott answers this, I will pick a winner for the subscription for the growing season. So the first one here from Daryl, can we have more than one user per subscription for our family? And the second one, can you remind me what the cost for premium would be in 2022?
So can you have more than one user? Yes, every subscription comes with 2 users by default. The person that signed up is the first user, and then you can add a second user in the app. So you have to log into the app, click your name in the top right corner, and you can add another user. You can have more than 2 users, and if you want to do that, you can go to the website and purchase additional. There's a small monthly fee if you want to add more than 2. The cost of premium, I believe, no, there's 2 ways you can do it: monthly or you can do it annual. I think monthly is $75 and annual is $825. So you'll see that if you go to our website, weatherlogix.com/agriculture, and click sign up, you'll see the 2 options there for those. And we'll be likely doing a spring sale in the near future, so also watch for that. Matt, if you want to do the draw, I see the question, so I'll read that.
The winner for the draw here is Ted Franzen. So Ted Franzen will be in contact with you. We'll send you an email with the details. So thanks everyone for joining. If there's any more questions, Scott will answer them. Looks like there's a few more questions.
Yeah, there's some more here. David, for the hail map, what is hail size based on? Is it radar? Yes, it's based on radar partly. So we have our own algorithms where we generate hail maps from radar. However, there's also the hail reports that we get. So we collect actual ground measurements of hail, and we use that to calibrate our maps. So we try our best to ensure they're very accurate, and we've found that ours are some of the best in the industry, and we work with a lot of the crop insurers on the prairies as a result. Next from Dean Farms, are you able to use weather data from any soil probes and weather stations around the prairies? Yes, we do. And in our app, if you select or if you go to the current conditions page in our app, you'll be able to select from a wide range of weather stations across the prairies. Some of them have soil moisture probes, especially the ones in Manitoba, so you can see the soil moisture data from them. In other areas, unfortunately, Saskatchewan, the province hasn't invested in that yet, but in Alberta, I believe they have. So Manitoba and Alberta, you should see some of that. Alberta, I'll have to just confirm. I think it's there, but I'll have to double check. But Manitoba, for sure, you can get it. We got a few more minutes for questions if there's any last ones.
Yeah, it looks like there was one more question from Mike there.
Mike asks, are thunderstorm outbreaks more possible this summer with more snowfall received this winter? It'll really depend on how the spring goes. If we turn really dry this spring and summer, that snowmelt moisture will disappear quite rapidly. But if we continue to see normal or above normal precipitation through the spring and summer, that would certainly suggest that thunderstorms will be a bit more probable. So it'll just really depends on how things evolve. If you believe our forecast, and I hope that it's correct and for my sake, but I hope it's wrong for farmers, that it'll be if you believe that it'll be dry summer, then likely less thunderstorms.
Maybe I'll just end off with a question that I've been hearing pretty frequently this over the past 6 months here. But what will cause the break in the dry cycle, Scott? And is it going to be gradual, or is it going to be pretty sudden that it changes to wet?
Well, to break the dry cycle, based on the research, would be a change in the Pacific Ocean temperatures, because that's what is currently believed to drive them. If I look at those temperatures right now, I really don't see anything that would suggest a dramatic shift. And based on the winter weather that we've had and the lack of strong systems coming up from the south, I also don't see strong signs of the pattern breaking. Usually when we get into the wetter cycles like we had in, let's say, years like 04, 05, or 2016, you had a lot more weather systems coming up from the southern US. And so under those circumstances, you would see the dry cycle probably break, but we're just not seeing a prolonged pattern shift to that type of condition. So unfortunately, I don't see it breaking, and the signals like changes in ocean temperatures aren't appearing quite yet.
All right, great. And looks like Scott has answered all the questions in the chat here. So we'll bring the webinar to a close then. If anyone has any other questions, feel free to email Scott or email Weatherlogix. I'm sure we'll be able to get back to you in a short amount of time here. Scott just posted up his email here on his slide. But other than that, I just want to thank everyone for coming again and attending the webinar. So have a great growing season.
Thanks, everyone. All the best.